Alrighty, good morning chemistry students, welcome back. Today we're going to be looking at accuracy and precision and the difference between them, and also how to do our first math calculation. So your learning target for today's notes, are to understand the difference between accuracy and precision and decipher if data meets these criteria. So you will need your note sheet for today, so if you have that, please make sure you pull that out or put it on your computer so you can type notes along with this video. You should have already completed your warm-up by now. Your warm-up today was to look around your room at home or your living room, wherever you're doing this assignment, and make 2 detailed observations and 2 inferences. Make sure you told me the difference between those things and don't just list them. Tell me, these are my observations, those are my inferences. If you didn't, go back and fix that. So to get started, what is accuracy? What is precision? So accuracy is how close you are to the correct value. So you're accurate if you're close to the correct value. Whereas precision is how close all your measurements are to each other. So just because you're precise doesn't mean you're accurate, and just because your measurements are accurate doesn't mean they're precise. So again, accuracy is how close you are to the correct value, whereas precision is how close all your measurements are to each other. And precision is very dependent on what tool you're using to measure. If you use something with higher graduation and higher milliliters counting, it's going to be more precise. Whereas if you're using something like a beaker, it's not going to be very precise. I think I have an example here. Not yet. So I want you on your notes to draw what you think accuracy and precision might look like in application. So I want you to draw me 2 pictures, one that's accurate and one that's a precise, like a dartboard. So your goal on the dartboard is to hit the bullseye. So draw something that would be accurate and draw something that would be precise, and I'm going to draw it on the board behind me. Alrighty, ignore my pizza pie real quick. Let me erase that. We were talking about charcuterie boards today in class, so I had to draw one, of course. So if I have my 2 targets, you should be drawing your targets. And if you haven't already identified what your accuracy and precision targets would look like, make sure you do that now. Otherwise, I'm going to show you. So accuracy is the correct value. So when you're throwing darts at a dartboard, your goal is to hit a bullseye. So you'd be accurate if you had all your darts right in the middle. Whereas you would be precise if all of your throws were near each other. So you'd be precise if all your throws were right here, all bundled up together. So notice that here, they're also all bundled together. So this is a picture of something that's accurate and precise, whereas this is just precise. We got something on the outside of the bullseye, so it's not very accurate because we generally don't want the outside, we want the middle. But it is precise because they're all close together. I don't really like having the screen really big on my face. Let's go back a little. So, some more pictures. If things are going to appear like that first picture, these dots up here, what would we describe those as? Good, both accurate and precise. It's showing accuracy and precision. What if the dots appeared like this? Not very precise, but pretty accurate. Although they are pretty close together, they're not super clumped, so they're not going to be precise. On a test or quiz, I will make it very clear if something is precise and accurate. What about these guys? So those are pretty clumped together. Good is pretty precise, but again, not accurate. And this demonstrates how I throw darts all over the place. So not precise and not accurate. So take a moment and sketch those onto your notes. This is one reason it might be difficult to take notes on a computer. Sometimes you will be doing a lot of drawing. It'll be especially important to have a note sheet and an actual pencil and paper when we get further along in chemistry when we're doing a lot of math. So let's do a practice problem. A student measures the length of a calculator 5 times. Their results are 4.32 inches, 4.40 inches, 4.37 inches, 4.52 inches, and 4.43 inches. Describe these results in terms of their accuracy and precision. So take about a minute and decide, is that accurate and is it precise? Oh, you can't even tell if it's accurate because I didn't tell you what the actual length is. The actual length of the calculator is 5.4 inches. Sorry. I'm going to change that right now. Give me one moment. All right, folks, we're back in business. So I would say that these are pretty precise measurements. He's on the student is only off by 0.1 or less in each of the cases. They're all pretty close to each other in measurement. However, he's pretty far off from the actual, so it is precise, but it is not accurate. You will have to be able to identify this on a test or quiz. So we are now going to be looking at percent error. So percent error is how poorly or how well done an experiment was done. How much error is there involved? So the percent error represents, an equation for that is YV minus AV times 100 divided by AV, where YV is your measured value and AV is the accepted value. So again, YV is your measured value. That is what you got in your lab, whereas AV is the accepted value. What were you supposed to get? So let's do a little practice problem. If a student measured the room width at 8.46 meters and the accepted value was 9.45 meters, what is their accuracy? So I'm going to write these down, and then I'm going to get this bigger in a second. So the student measured the room. Oh no, the lights went off. I'm sorry. I gotta turn them back on. One moment, please. All right, sorry. The lights are back in business, and we have things written down. So our measured value was 8.46 meters, while our accepted value was 9.45 meters. So all we're going to do in this example is just plug them into our formula, which we know is our percent error is equal to your value. Our value is always what we're going to measure. So we're going to do 8.46 minus our accepted value, 9.45, times 100 divided by the accepted, 9.45. Oh, you can't see anything. Oh, wrong way. And then we're going to solve. So of course we're going to do the parentheses first, 8.46 minus 9.45. I don't have a calculator, so I don't know what it is. Hopefully you're solving it on your own at home. We're going to get negative 0.99 times 100 divided by 9.45. To eventually get 10.5%. So 10.5% should be your answer. Hopefully if you did that math correctly. Let me double check my math real quick. Yes, 10.5%. So note that the meters is going to cancel, leaving us with a percentage since we're multiplying it by 100, so we're getting a percent. An acceptable percent error is within 5%. So this wouldn't be acceptable. We would want to redo this experiment because there's too much error involved. Lucky you won't be getting graded on your percent error in class. General chemistry students, you generally will not calculate this too often, but you do need to know how to do it. So we're going to stop this video here for a moment, and then we're going to resume it with the next video in a little bit. So make sure you finish up these notes and then revisit our next video. Thank you.